Hello everyone, and welcome to Module 4. Now in this module we're going to talk about probability. The title is What are the Chances? And this is a formula-free probability activity from me, Scott Falstrom. All those rhymes there makes me want to harken back to one of my favorite movies. Anybody want a peanut? So let's take a look. We're going to start with some background and kind of key information as we move through this module. Probability can be a time-consuming topic if you cover it in a very traditional way. Perhaps you've had a course as a teacher in your background that was maybe an entire term long or longer probability theory course. It doesn't have to be that way, but again, if you're getting in depth with probability, it usually takes a lot more. A lot of terminology, things can be nuanced and often complicated. So thankfully we've got some guidance. What should we emphasize or de-emphasize in our courses? So let's take a look at that. What should we cover and emphasize? There is the GAZE report that we referred to at the beginning of this course, and the link is still here. You can also see it back in the introductory module. But if you do just kind of Google GAZE report, it'll bring you to this page, and make sure you choose the one that is the college report. And when you get into it, it does have quite a few recommendations and suggestions. And some of those are for topics to be omitted. As you read through that list of topics to be omitted, it is the suggestion of this group that you start considering ways that you can focus on items and content that are actually at the level we need and not just reteaching things that they've seen before. And in my experience, a lot of teachers may not even know what really is covered in prior courses, and they might believe that it's not part of the curriculum. So the suggestion here is that instructors may want to briefly review some of these topics. Again, this should take little time. So if you look through your course, you might be wondering, well, wait a minute, I spent a good amount of time on the basics to make sure that they have them. Maybe as you look back, how much time could you save if you were following that prior suggestion? And really, what concepts have students already seen in their coursework and their experience? So this link takes us to the corestandards.org. You'll notice at the end the link has a /SP. That indicates that we're moving to statistics and probability. So I'm going to switch over to this website. What you get a chance to see is grade levels 6 through 8, and there's also a link on the side that takes you over to statistics and probability at the high school level. And I encourage you to go read this over to kind of understand, hey, what topics have been covered in the state that might relate to what I'm teaching. So it does start as early as grade 6 with understanding statistical variability, summarizing distributions. As you move down, using some sampling to draw inferences, again at a basic level, informal comparisons between populations. As you get down to grade 8, you start looking at bivariate data. Things maybe that you might think, hey, no one would have seen that yet. They get it in grade 8. They get two-way tables, relative frequencies. And that topic is going to be something we're basing our work on in this module. Scrolling back to the top, if you do choose the statistics and probability piece, you can actually look and see there are other topics here that are covered at the high school level. Based on the GAZE recommendations, if you're covering things like conditional probability, those topics are listed as outcomes there, but it might be good to have reviewed those in your intro course. Might be a good idea to use the activity in our course as a way to introduce the ideas to students who have not seen them in a way that doesn't get as abstract as a traditional approach. Well, let's jump back to the slide presentation for this module. So one of the other suggestions for topics to be omitted from the GAZE recommendations is probability theory. The original report emphasized a lot less emphasis on probability, and the current report does continue to endorse that. Again, students do need some basic probabilistic thinking, and basic probability and rules might be something you want to teach, but the GAZE goals and recommendations can be met without those specific topics. So introducing them and integrating them into something else as opposed to spending specific time just on basic probability and rules about random variables, for example. This might be something that goes counter to the way that you teach your course. Some of you might have 2 weeks or more where you might do probability theory and maybe even cover things like combinatorics, different ways of counting, combinations, permutations, a lot of ways to bring those ideas in. But again, for an introductory statistics course, you may not need those. Now, we do need probabilistic thinking. So if you were thinking, oh, this is going to show me I don't need probability at all, it doesn't have to be all or nothing. The only issues with the traditional approach is it tends to take a lot of time. It can typically take a couple of weeks or more to get through a good foundation of probability in that traditional way. It's a stumbling block. But we know the concepts are important, and in order to understand statistical inference, we need to have some of that. The solution is maybe not that we're not going to cover topics, but maybe the way that we cover them makes it hard. And so our solution is just a different approach to probability. As you start the activity, you'll notice the title, What Are the Chances? Really gives students the idea to think, hey, okay, what are the chances? Don't even use the word probability to start it off, but it's a small table. We're going to start with something that's already completed. Now, the goal of using a completed table is that the numbers are already present and you can point out very quickly basic probability ideas without having to do weeks of P of A and P of B situations. The numbers are here, and students have a little bit more of an intuition about this, especially now that it's contextualized. So the first few questions, the language does change a little bit. The language starts off with how many people, and then you'll notice it moves to what is the probability, and it moves to how many people and what percent or what percentage. So this language is intentional to try to balance the ideas that we're not just counting anymore, we're looking at what are the chances. As you move through this activity, we will extend this to conditional statements. And typically, again, this is a confusing topic for students, but without using a lot of the strong notation or developing all of those additional pieces that can make it confusing, try to give some examples of what we're doing and why it's so relevant. What if we know that someone died from non-COVID related reasons? Find the probability that they're fully vaccinated. We know that's just a single row of the table. So you could highlight that as you're going through and illustrate, hey, we're only looking at this row. So our result would be 7 out of 30. Again, as you switch gears, it's quick to say, well, what if I'm looking for the probability of a non-COVID related death if I know the person was vaccinated? So this is reversing that situation. And I think it's really important to have not just one direction, but have the other direction in the table initially, because otherwise students will start kind of thinking, hey, if I just switch those around, it feels like it should be the same result. And we want to definitely show them that it is not. Now, with many of our recommendations, you've seen as soon as you cover a context, instead of just moving on, maybe talk about that context a little bit more. So the follow-up related to the study that we saw, there might be some questions in students' minds. So instead of just thinking of this as my way to start you on probability, also think this is a way to bring a context to them that can make this more real. This article talks about things like, hey, we shouldn't draw a cause and effect conclusion because this is an observational study. It's a good chance to bring the terminology from earlier in your course up yet again. So it's also a good chance for students to bring in their perspective. What are some other factors that might contribute to that observed difference? This might be fairly new if you're more a traditional probability teacher, but as you go through the rest of this activity and as you try this with your class, I think you're going to find it to be not just more effective and maybe even free up some of that very valuable time, but also kind of fun. So anyway, you got this. All right, off you go.